Hi, and welcome back for another exciting Math 1040 lesson. This is the lesson 2 about sampling, which is a really important topic that will be important all semester. And let's get into it with basically what is it and some vocabulary definitions. First, we want to talk about a population versus a sample and a parameter versus a statistic. Keeping these ideas straight is going to be really important. So the population is the entire collection of entities being studied. It's the large group. And a parameter is a measurement that we're going to try to find, that we want to find, that summarizes some characteristic about the population. So for a numeric variable, what that would be is a mean. That's just a word for average for the entire population. And for categorical variable, it would be a proportion of the population that's a certain category value. A sample, on the other hand, is a subset of the population. It's a smaller group. Sample is smaller, or it's subset, that we actually study. And a statistic is a measurement that we get from sample data. And typically what's happening is we want to study a population, we can't, it's too hard, it's too big. So we take a sample and we get a statistic, and the statistic is an estimate of the parameter. So let's actually go over to the car data and talk about this. So I actually happen to have population data here, which is not usually the case, but we have data for all 2024 car models, and we might be interested in the gas mileage. So each car has a different gas mileage, and I'm going to scroll to the bottom. So we have 1,220 cars, and our parameter could be the average. I'm doing row 3 because the first 2 rows are not actual information. Oops. So I'm just going to take the average of those 1,220 numbers. So that's our average gas mileage, 36.04. That's the parameter that we would be interested in measuring. What's the average gas mileage of the population? Typically, we wouldn't necessarily have all of the data. We would instead have a sample, which I have over here. A sample is a subset of data that's participating in the study. So over here, I've generated a random sample, or basically I've had Excel randomly select 70 of these and generate a new tab. So this is a subset. It's not all the cars anymore. It's just 70 of the cars. And we have the same variables. And we're going to do this gas mileage again. So we didn't get the same answer, and that's actually totally expected. So let's back up a little bit. This number here, the average of just these 70 values of the 70 cars that were randomly chosen to be in the study is a statistic. So for the whole population, the average of all of the values was a parameter. And for the sample, the average of all the values was our statistic. So one way to remember this is these go together, the letters. Population, parameter go together. Sample and statistic go together. And also the sample is a smaller set. So let's talk about something about what is a sample? How did it come from? How did we get it? To make a good sample, it needs to be random. And what random really means is every member of the population must have an approximately equal chance of being selected in the study. So if I just went here and chose the first 70, that's not random. I only get Acuras and Audis mainly, which wouldn't necessarily represent the population. Basically, we have all these names in a hat, and we just draw them out. Each one needed to have an equal chance to be included in this sample over here, and they were the way I did it. Every member needs to have approximately equal chance to be selected. And we do this with a random process, random number generator. That's what I did. Names out of a hat, and we'll talk about some more advanced techniques shortly. This is so important, guys. Your sample needs to be random and not biased. Because we're using this sample to estimate the parameter, we don't want any bias. So the random sampling process minimizes what's called selection bias and makes the sample representative of the population. If the sample is not representative of the population, we're dead. The statistics we would want to do later are not legit. So you have to have a random sample. And that's actually going to end the video. I'm going to make a second video about this next part.